try to solve Leetcode problem 41. First, missing positive. We are given an unsorted integer array nums. Return the smallest positive integer that is not present in nums. So for example, when 2, 3 is not present, so we're gonna return 3. Yeah, you must implement an algorithm that runs in O(n) time. So this means we cannot sort the array nums because that is n log n. Yeah, we must run it in O(n) time, and we must use O1 extra memory. It means we cannot use memory like O(n). Yeah, so by those two constraints makes the problem really hard. Yeah, but let's just analyze the examples. So the nums length is 10 to the power of 5. Yeah, and the nums I is a really big number. So how can we solve it? Yeah, so as I explained, we will not use the sorting because sorting will be n log n time. Yeah, maybe we try to use some memory. Maybe we try to find out how can we solve it easily. But for the numbers, you know, the length of the nums is 3, but this number, the result is 3. So what's gonna be the maximum result? So for example, if this number is 1, 2, 3, yeah, so the maximum result may be 4. So this is gonna be the maximum result, or it may be 1, 2, 3. But the maximum result is the length of the nums plus 1. So it's gonna be 4. And in this example, you can say it is 2. The length of the array is 4. It is okay. So for this one, the length of the array is 5, and the result is 1. Yeah. So we need to find these constraints. So all the numbers should be between 1 to the length of the nums plus 1. Yeah. So what if we use some extra memory? Yeah, let's just use some extra memory to see if we can solve it. So we're gonna use some memories like S. We're gonna use a set of nums. Now we are going to check. So for I in range from 1 to the length of the nums. So what is the length of the nums? It is 10 to the power of 5. So we're gonna use 10 to the power of 5 plus 1. So here we're gonna plus 2. Yeah, because the numbers can be from 1 to 10 to the power of 5. If it is 10 to the power of 5, the next number is 10 to the power of 5 plus 1. So that is why here we're gonna need to plus 2. Yeah, so we just need to check if I not in S, we're gonna return I immediately. Yeah, but we cannot use this way because we cannot use extra memory. So yeah, let me run it. But we're gonna use this kind of idea to solve the problem, and this is really important. Yeah, let me just run it. As you can see, it works and it's pretty fast, but this is not what asked because we should not use memory. But this constraint is really important. It means all the numbers are going to be from 1 to length of nums plus 1. Yeah. Now we're going to use this kind of strategy to solve the problem. So we have the length of the nums. Yeah. Yeah, but for this problem, that is really hard. It is hard not because not because it's hard to think, but there's a lot of edge cases we might make mistakes. Yeah, so we have to follow the procedures of solving such problem because we're gonna use the index hash. I mean, for each of the positions of the index, we're gonna use it as a hash to check if this number exists or not. Yeah, because the index of the nums array is from 0 to n minus 1, so we're gonna set it from 1 to n. And then at each of the index, we're gonna check if this number exists or not, because all the numbers is just coming from 1 to n. If it does not exist, it must be n plus 1. So the first step is gonna be the set infinity, because if the numbers not exist, I'm gonna set it as infinity. And the second step is gonna be set negative, because I'm gonna use a negative to represent this number exists. And the third step is going to be find out. Yeah, it seems you have to follow such kind of procedures to solve the problem of the index. We're going to use index as the hash table for all the nums. So for example, index 0 going to represent numbers 1. We're going to check number 1 exists or not. Index 1, we're going to use it to check number 2 exists or not. Index 2, we're gonna use it to check number 3 exists or not. Yeah. So if this is a negative value, this is a negative value, it means we didn't find it. This means the numbers must be 4 because we are giving 1, 2, 3. Because 1, 2, 3, we set it out to be the negative values. If there's no positive values, so we're gonna return a 4. Yeah. So this is why we're gonna solve it like this way. So for example, if 2 is still a positive value, so we're gonna return 2. This is the index 1 plus 1, so it's gonna be 2. It means 2 not exist. Yeah. So for example, if we are giving a number, it is like 0, 1, 3, definitely we're gonna return 2. But how can we do that? First of all, we're gonna set 0 and the negative values, and all the values more than the length of the nums array to be infinity. So 0 gonna be infinity, and here gonna be 1, 3. Yeah, this is the first step. And the second step is that we're gonna check some values. If it is not infinity, we're gonna check. If it is 1, we're gonna set it infinity here as a negative infinity, and then we're gonna check this 3. Yeah. So this 3, it means the index 3. So the index 3 is gonna be minus 3. So this is gonna be the result. Now, third step, we're gonna use the find out. We're gonna find out it if there's a positive value. This 1, it means it's not exist. So it's gonna be the index 1 plus 1. So we're gonna return 2. Yeah. So this is why we have to follow such procedures to solve the problem, and that is why it is a hard problem. Normally, if you can't find such procedures, yeah, you cannot solve it. And the procedures is we're gonna use the index as our hash table to solve the problem. Now let's try to solve it. So for I in range n, if nums I is less than or equal to 0, or nums I more than the length more than n, so we're gonna set nums I to be the infinity. So this is the first step. Now let me just return something, and let's check what is the nums after the first loop. Yeah, we're gonna check if we set it to be infinity or not. Let's just check this one to 0. So we're gonna set the 0 to be infinity. And for the second example, yeah, maybe this one, we're gonna set a -1 to infinity. That is still okay. And let's check the third example. We set all to be infinity because that is not inside of the range. Yeah, as you can see that. Now we're gonna follow the second step. We're gonna set the negative. So we're still gonna use a for loop. So for I in range n, we have to check the nums I if absolute of nums I are not equal to infinity. Yeah. Now we're gonna find this nums. We're gonna use a v as this nums. So v should be the absolute. Yeah, this is why it is hard, because we have to use the absolute value to check. If we forget any of the absolute values, we're gonna make mistakes. Yeah. So absolute of nums I. Why we're gonna use absolute? Because sometimes, even for the first time, this nums is positive, but it may become negative. This is why we have to use absolute each of the time to check the values, because it can be set to negative. But for the index check, we have to use the positive values. Yeah. Now this v is a positive value, so we're gonna set it. So this is gonna be nums v minus 1 should be equal to the absolute of nums v minus 1, but we need to set it to be a negative value, so we're gonna need a negative value like this. Now let's just check out what is our nums. Yeah, we have to check it before we write the next loop. Yeah, because otherwise, if there's a mistake in any of the loop, we're gonna make a mistake. This is why we have to check it gradually. Now we're gonna check the second. For this example, so it is a positive number. It is 1. It means at index 0. Yeah, so this is 2. Number 2, it means it's gonna be at index 1. It's gonna be -2. Yeah, this is why we're gonna use it to check. If it is a positive value, it means we're gonna return index 2 plus 1 is going to be 3. So this is why it is 3. Yeah. Now we're going to try to use the second loop, find out. So for I in range n, we're going to check if nums I is a positive value. If it is more than 0, so we're going to return I plus 1. If we didn't find it, of course, we're going to return n plus 1. It means if this is 1, 2, 3, we're going to return 4. Yeah. Now let me run it. Yeah, it seems it passed all testing cases. It should work. Yeah. Now let me delete the print and check if it can pass all the testing cases. I mean, the coding is not so long, but it's really difficult to write. Yeah, you have to follow exactly the procedures like this. You have to set the infinity first, and then set the negative, and then find out. Yeah. As you can see, it passed, and it's pretty fast, and the time complexity is O(n), and the space complexity is O1, because we didn't use any actual space. Thank you for watching. See you next time.